So, a little bit idea I have already discussed when we started this chapter. So now we consider a function of three variable, and let us assume that this function is continuous. In a closed and bounded region D, which is subset of R3, such that the bounding surfaces of D consist of a finite number of smooth surfaces joined along the continuous curve. So you have, so here the domain of the function is defined in R3. It is a closed and bounded region, and not only that, the boundary of this region D will be surfaces. So these surfaces should be finite in numbers. Okay, so only
boundary
those
of
kind
this
of domains which satisfy these conditions are considered to define the triple integral. So as I said, now we have three, as I said before, we have three variables x, y, and z in the domain. So we partition the x-axis, y-axis, and z-axis. The domain, so this is the partition of this domain. Okay, so the partition, you remember you have, when you have just single variable on the x-axis, and the function was and f was a function of just single variable x, and you want to integrate this function over the interval a to b. We partition the interval a to b equally, and then we moved to a function which is a function of two variable, and let us say that a, b, c, d. This is the region, this is the domain of the function. So what we did is we partition along the y-axis and along the x-axis, and in that way we have made rectangular squares. Here we have, in the one variable case, we have intervals. So from interval we move to squares when we partition the domain of the function, and when we move from R2 to R3, these squares will become the rectangular cells. Okay, so let us assume that the rectangular shapes, you partition x, y, and z in such a way, x, y, and z axis in such a way that you get rectangular cells, and let us number them, these rectangular shapes, cells, as v1, v2, so on to vn. So there are n rectangular cells which lie completely inside the domain D. So that means the volume of this rectangular cell will be delta x, delta y, delta z, where delta x is the length of the partition on the x-axis, delta y is the length of the partition on the y-axis, and delta z is the length of the partition on the z-axis. And if you take the union of these cells, these rectangular cells, then the union may not cover the entire cell, entire region D. But when you refine your partition, which means delta x, delta y, and delta z tends to 0, which also means n goes to 0. That means the number of rectangular cells goes n goes to infinity. That means the number of rectangular cells goes to infinity. Then larger and larger portion of D can be covered. And this was a similar situation we had seen for the case of two variable, function of two variable. Okay, so these rectangular cells we can identify, and then we refine our partition in such a way that delta x, delta y, delta z goes to 0. In other words, the number of cells goes to infinity. Then you cover the entire domain D, all the area in the domain D. And now you can define the Riemann sum as the value of the function at point xk star, yk star, and zk star, where the point xk star, yk star, zk star lie inside the kth rectangular cell times the area of the kth rectangular cell, and then you sum over all the cells. That means sum over k from 1 to n. So this is how you construct the Riemann sum. And then when n goes to infinity, which means delta x, delta y, delta z goes to 0, which essentially means refining the partition, then this sum, this Riemann sum, will converge to some number S, and this number is denoted by the triple integral over the domain D of the function f. Okay, so this is more or less very simple extension of the double integral to the triple integral in the rectangular coordinate. And in the same way, you can extend the notion of triple integral or double integral to the n-dimensional space, n-dimensional Euclidean space. Okay, so this is the basic intuition behind the construction of the triple integral. Now we again see, we have seen Fubini theorem in the double integral. So we will see the Fubini theorem in triple integral also. In double integral, we have different forms of Fubini theorem. If you recall, here also we have different forms of Fubini theorem. And these forms of Fubini theorem depend on the type of domain on which the function is defined, type of the domain of the function f. Okay, so let f be a continuous function on a bounded domain D, where the domain D is given by all x, y, and z, such that x lie in the interval a to b, y lie in the interval c to d, and z lie in the interval e to f. So this is basically a domain of rectangular cell. Okay, so in that case, so there is a typing mistake. This we replace this A by B. A is used for area, and area means you are in R2. That means the function is of two variable. Okay, so if you have this domain of which is of the type rectangular cell or cuboid, then the triple integral can be simplified as the integral with respect to x, with respect to y, and then with respect to z. And with the help of this Fourier theorem, we will be able to solve or identify or calculate explicitly the value of the triple integral if the domain is of this type. So you have two conditions here. First condition is f should be continuous on the domain D, and the second condition is that the domain D is a cuboid. Fine. Now here the order of integration is x first, then y, and then z. But this can be performed. This integration can be performed in any order. Keep in mind this domain. So if domain is of rectangular, domain is a rectangular cell or cuboid, then the order of the integration can be performed in any order. So here, the first on the slide, you see that the integration is performed with respect to the variable x first, then with respect keeping y and z constant, and then it is performed with respect to the variable y, keeping z as constant, and then with respect to z, keeping then there is no other variable. So then with respect to the variable z. But you can interchange the order also. You can perform the integration with respect to the variable x first, keeping z and y constant, then with respect to z, keeping y as constant, and then with respect to y. You can also perform the integration first with respect to y, keeping x and z constant, then with respect to x, keeping z as constant, and then with respect to z. Or you can say y first, then z, and then x. Or you can say z first, then x, then y. Or you can say z first, then y, and then x. So in any order, you can perform this integration, provided the domain is of this type. If you change the domain of the function, then you have to see which integration to be performed first. Okay? And how this range to be defined.
Sir, can you give example where it is not defined?
What is not defined?
This Fubini theorem for triple integral.
Fourier theorem for triple integral. So basically, it really depends on the domain D. So if domain is very complicated, it cannot be defined. As I said, you can when you look at the boundary of this, the boundary is quite good. Boundary of the cuboid. So if you have some bad boundaries, then you cannot have this equality.
Sir, as in there is no continuity.
Continuity still can be overcome. Continuity can be overcome to a certain extent. If you have finite number of discontinuity point, then the function can still be integrable.
So, sir, then where
If
it is
you
not
have
valid?
But if you have infinite number of discontinuity, then you cannot find the integral of the function. For example, if you construct a function such a way that at every point this function is discontinuous, every points on of its domain. So you have infinite number of points where the function is discontinuous, then you cannot perform the integration. For countable number of discontinuity, you can still define with some complicated, like little bit complication, you can still define.
Okay,
So
sir.
basically, you have to think of a domain which cannot be expressed in this way. So one domain is this one, this rectangular cell. The other type of domain where Fubini theorem can be applied is this one. So here you need to ensure you need to ensure that G2 is greater than equal to G1 for all x and y inside the domain. So they can be equal, but they should not cross each other. So if you have that complicated domain, then you cannot. In some cases, you can still define because you can split the domain in such a way that you can find the integral. But in other cases where you have domain where they overlap, they crisscross, then it may become complicated and you may not define. You may not define the Fubini theorem. Okay. Is it fine?
Yes, sir.
Okay, so now let us consider this example. We want to find the triple integral of the function 12x y squared zq over the domain D, where the domain D is consists of all points x, y, z, such that x is inside the interval -1 to 2, y is inside the interval 0 to 3, and z is inside the interval 0 to 2. So if you recall, when we were calculating the double integral, first step we did is to the first step was to identify the boundary. So here also we will identify the boundary, and boundary in this case will be a kind of surface, not the curves. So what are the boundaries here? From the interval, from the values of x, the boundaries are x is equal to -1, x is equal to 2. So that means you identify x is equal to -1 and put a plane there. And similarly, x is equal to 2, you put a plane there. Then from the limits of y, you have y is equal to 0, y is equal to 3. From limits of z, you have z is equal to 0 and z is equal to 2. So plot these planes on the graph. This gives you figure 37. So here you have this origin 0, 0, 0. Yeah, 0, 0, 0. Y is also 0 here. Z, this is x-axis, this is y-axis, and this is z-axis. And this point is 0, 0, 0. This is x is equal to 2. So on x is equal to 2, you have this plane. This plane. Okay. Similarly, you have x is equal to -1. So x minus 1 is this one. So you see you have this inner plane, this little bit brown. Okay, so you have this plane. Then you have y is equal to 0 and y is equal to 3 from the limits of y. So we go to the y-axis. On y-axis, we have y is equal to 0. That means x-axis. So you see this is the plane. Y is equal to 0. And then y is equal to 3. This is 3 here. So this is the plane. Y is equal to 3 here. And then you go to z-axis. Z-axis, you have z is equal to 0 and z is equal to 2. So this is my z-axis. Z is equal to 0. So basically z is equal to 0 means you have xy plane. So you have this, the one inside. You see the bottom, that is z is equal to 0. And then z is equal to 2. So z is equal to 2 is this. So this top surface. Okay, this is z is equal to 2. And the common area is this saddle region given in the picture. So that is done. Now look at the projection of this region in the xy plane. The projection of this region in the xy plane is this rectangle. Okay, the bottom surface when z is equal to 0. This surface is plotted here. This is the projection. So from the right picture, one can easily see that you have this x-axis here, and this is y-axis. X lies between -1 and you see that this is -1 and 2, and y lies between 0 and 3. So you have 0 and 3. So this is the rectangle that you obtain, which is the projection of the region, projection of the domain, this three-dimensional rectangle in the xy plane. Okay, so the triple integral in this case using the FEB theorem will be using the FEB theorem. The triple integral will be the triple integral over d will be equal to, as if you are integrating individually. So here the order is that we have done is on with respect to z first, then y, and then x. Okay, so you just when you do the integration with respect to the variable z, that means the first integral, this integral, when you evaluate this, you keep x and y as constant. So that means this will be equal to x and y are constants. You can take this out of integration. 12xy square will come out of the integral. Dz, which means you have 12xy square and z cube is z raised to 4 divided by 4 over the range 0 to 2, which means you have this 448 xy square. Okay, so you get 48 xy square here. Now you evaluate this integral with respect to the variable y, keeping x as constant. So when x is constant, you can take this 48x outside, and you have integral 0 to 3 y square dy, which is 48x y cube by 3, 0 to 3, which is how much you will get? You will get 432x. And then integrate with respect to the variable x, you'll get 648. Right? Now you can check by changing the order of integration that you will arrive at the same answer. So instead of integrating with respect to z first, then y, and then z, then x, you integrate in different order. Let's say with respect to y, then z, and then x. So with respect to y, you identify the limit. The limit of y is 0 to 3. So you write the first integral from 0 to 3. Then you have the variable z. So limit of z is 0 to 2. So you write 0 to 2 here. So if you change the order, you have to change the limit of the integration in that particular order. If you are integrating with respect to y, then you put the limit of y there, right? And in the same way z. And then with respect to x, the limit of x given in the domain is from -1 to 2. So you put -1 to 2 here. Okay, in the same way, you can have different orders. All orders are given on the slides. And you can verify at home that in every order you will get the same answer. Okay, it illustrates that Fugni theorem holds. So now let us consider we do not have this rectangular box or the rectangular cell as the domain. Let us consider we have a domain D, which is a solid bounded from below by the surface that is equal to G1x, and from above by the surface that is equal to G2x, where G1 is less than G2 for all xy coming from R. And what is R? R is the projection of the region D in the xy plane. Fine. So you have two surfaces, G1 and G2. These surfaces are defined on the projection R of the domain D in such a way that G1 is less than equal to G2 for all xy belonging to the projection R of the region D. G1 and G2 are also assumed to be continuous functions on R. This type of solid is known as simple XY solid. The surfaces may touch each other because you have equality, G1 is equal to G2, but cannot cross. So if you have this, as I said, if you have surfaces where G1 and G2 not only touch but also cross each other, then in that case you cannot use Fubini theorem. Now let us also assume that the projected region R. Now R is the projection of D in the XY plane. So that means R can also have many different types. Because now you are in, when you project D in the R2, then basically you have a region in the XY plane, and if you have such region in XY plane, then whatever you have done in the case of double integral, or whatever types of Fubini theorem you have learned in the double integral, those forms can also be incorporated here. So that means I can assume R, the projected region R, can be of the form all xy such that x is lying between two, x lying in the interval a tilde b tilde, y lying in the interval g1 tilde g2 tilde, or R can be of the type where y lie in the interval c tilde d tilde and x lie in the interval h1 tilde h2 tilde. And here we again assume that the functions g1 tilde, g2 tilde, h1 tilde, h2 tilde are continuous functions. Okay, so this whole paragraph is dedicated, the first paragraph on this slide is dedicated to explain what type of domain we can use or we can consider in the Fubini theorem. Okay. So mainly there are two things here. The first thing is that the solid D is bounded by two surfaces G1 and G2. Two surfaces Z is equal to G1 and Z is equal to G2. And G1, G2 are, G1 is less than equal to G2. Second thing is that R is the projection of the region D in the XY plane. And R can be of the kind that we can assume in the Fubini theorem for the function of two variables. Okay, so if these conditions are satisfied, then the triple integral over the domain D can be expressed as the double integral over the region R, and here this inside this double integral of this function, which is the integration of f over the limits g1 to g2 with respect to the variable z. Okay, so this is the double integral of this function, and yeah, because you have this d. Okay, and here again you have this, for the double integral you have Fubini theorem. Okay, so this is the, so basically now you can also change the order of integration, and all those things you can do here also. If you are able to identify the surface is appropriate, you can do the change of integration as well. Now, what is what is most important in the triple integral is that how to find the triple integral. So this slide explains you the procedure for finding the limits of the triple integral. We have seen the procedure for finding the limits of the double integral in rectangular coordinate and in polar coordinates. Now we are going to see the procedure for finding the triple integral in the rectangular coordinate. As before, the first step is draw or sketch the region D and its projection in the XY plane. It is not necessary that when you project the region D, you always have to project the region D in the XY plane. You can project the region D in the YZ plane also, but accordingly your limits will change. You can project the region D in the ZX plane as well, right? And then you change the order of integration. So here the procedure is explained by the procedure explained for projecting the region XY plane. Okay, so first project the region D in the XY plane and the projection is R. Then the second point is draw a line parallel to the Z axis starting from a point XY in the region R. So in the second step, what you do is first step is you have region D, you plot this region D in R3, project the region D in the XY plane, you get the region R. Now from this region R, you pick a point inside the region R. From this point, you start a line which is parallel to the Z axis. Okay? You start a line which is parallel to the Z axis. Then identify the surfaces where this line enters the region D and the surface where this exits the region D. Fine. This gives you the range of Z. So if this line, which is parallel to the Z axis, enters the region when Z is equal to G1x, enters the region on this surface, and exit the region on the surface Z is equal to G2x, then the limit of Z will be from G1x, G1 to G2. Fine. So you are able to identify the limit of Z. Now limit of X and Y can be identified from the region R as we have done in the case of double integral. ठीक है? So यहाँ पे केवल तुम्हें Z का लिमिट आइडेंटिफाई करना है और X और Y का लिमिट जो डबल इंटीग्रल का प्रोसीजर था उससे आइडेंटिफाई हो जाएगा. अब यहाँ पे क्योंकि डबल इंटीग्रल का यूज हो रहा है तो डबल इंटीग्रल में जितने भी टेक्निक्स तुमने पढ़े हैं, whatever techniques you have done in the double integral, you have seen change of variable, you have seen change of integration, you have seen polar coordinates, you have seen rectangular coordinates. All those techniques can be used here. Okay? So you just have one additional integral, which is integral with respect to the Z variable. And you just have one additional step, how to identify the limit of Z. And limit of Z, I repeat it again, रीजन D जो रीजन ऑफ इंटीग्रेशन है उसको प्लॉट करो, वो सॉलिड होगा, उसको प्रोजेक्ट करो एक्स वाई प्लेन पे, जो प्रोजेक्टेड रीजन होगा उसको वो एज्यूम करो कि R है और फिर R के अंदर एक पॉइंट लो, उस पॉइंट से एक लाइन स्टार्ट करो जेड एक्सिस के पैरेलल और फिर देखो कि वो लाइन डी में कहाँ पे एंटर कर रहा है। जहाँ पे एंटर कर रहा है वो एक सरफेस होगा, वो उसका लोअर लिमिट हो जाएगा जेड का। और फिर वो कहाँ पे एग्जिट कर रहा है डी को, वो भी एक सरफेस होगा, किसी सरफेस पे एग्जिट करेगा, वो जेड का अपर लिमिट हो जाएगा। अब जेड का लिमिट आइडेंटिफाई हो गया और एक्स वाई का लिमिट जो रीजन आर है, आर क्या है, आर है डी का प्रोजेक्शन। ठीक है, तो डी का जो प्रोजेक्शन है आर, वो एक्स वाई प्लेन पे लाई कर रहा है। एक्स वाई का लिमिट जैसे डबल इंटीग्रल में आइडेंटिफाई किए थे वैसे ही होगा। अब वहां पे तुम्हें अगर पोलर कोऑर्डिनेट से अगर प्रॉब्लम्स सिंप्लीफाई होता है तो पोलर कोऑर्डिनेट में चेंज करके कर सकते हो डबल इंटीग्रल का पार्ट। अगर तुम्हारा लगता है कि रेक्टेंगुलर कोऑर्डिनेट में हो सकता है तो रेक्टेंगुलर कोऑर्डिनेट से कर सकते हो, जो भी तुम्हारा कन्वीनियंट है। डबल इंटीग्रल के जितने भी टेक्निक तुमने पढ़े वो सारे टेक्निक यहाँ पे अप्लाई कर सकते हो। इज इट ओके? एनी क्वेश्चन है? कोई ऐसी चीज जो समझ नहीं आई हो यहाँ तक? Okay. So on the next slide, and the next slide is nothing but you just have to project in a different way. Instead of projecting in the XY plane, you project in the XZ plane and repeat the same process. You get this one. You project the region in the YZ plane. You get this one. All of these will be equal. The triple integral, when the projection is done in the XY plane, when the projection is done in XZ plane, and when the projection is done in YZ plane. Okay, all these cases will give you the same answer if you are able to find it. Sometimes it happens that when you project the region in the XY plane, then your calculation is easier. But if you try to solve the same problem by projecting the region D in some other plane, let's say YZ plane or XZ plane, then the calculation may become complicated and sometimes you may get stuck. Fine. So there you have to identify your own brain, your own creativity, where you have to project the region D so that your calculations are simplified. ठीक है, तो यहाँ पे तुम्हें अपना दिमाग लगाना होगा कि XY प्लेन में प्रोजेक्ट करने से कैलकुलेशन सिंप्लीफाई होगा या YZ में सिंप्लीफाई होगा या ZX में सिंप्लीफाई होगा। ठीक है, जो भी कन्वीनियंट तुम्हें लगता है that you can apply. Just like the double integral, we have this linearity rule. On double integral and the single integral, you have this linearity rule which says that the triple integral of the linear combination of the functions f and g is same as the linear combination of the triple integrals of these functions. And then you have dominance rule which says that if f is greater than equal to g throughout the region D, then the triple integral of f will be greater than equal to the triple integral of g. And subdivision rule, just like the subdivision rule in the double integral, if you are able to divide the region D into two non-overlapping regions, That means D is equal to D1 union D2, but the intersection of D1 and D2 is phi empty set. Then the triple integral of F over the region D is same as triple integral over the region D1 plus the triple integral over the region D2. And this is subdivision rule. All right. So now we solve a couple of questions on triple integral. So let us see this question. So here we want to integrate x square over the region bounded by x is equal to 0, y is equal to 0, and z is equal to 0. What is x is equal to 0? What is x is equal to 0? In R3?
YZ plane.
YZ plane. What is y is equal to 0?
XZ.
XZ. Z is equal to 0 is xy plane. ठीक है? ये surfaces हो गया. Now we have another surface. So you have this. You can see three surfaces here. एक ये जो है ये इस साइड पे है, एक यहाँ पे है, and एक bottom पे है. So this surface is xz plane. The one at the bottom is y, xy plane, and this one on this side is yz plane. Okay, which corresponds to x is equal to 0, y is equal to 0, and z is equal to 0. Now you have another surface x plus y plus z is equal to a, and that you see this you see this one, the slanted one. So that surface you plot. So the region bounded by this is this the region given in this first picture. So my first step is done. I'm able to plot all the surfaces. This entire domain is plotted in this first picture. Now what is the second step? In the second step, we project the given surface in the xy plane. So projection you can clearly see from the picture is this triangle. This triangle is the projection of this shaded region, and this triangle is plotted here. So first of all, what is this line? What is this line?
X plus y equal to A.
Say again.
I think x plus y is equal to A.
तुम दोनों एक साथ बोल रहे हो.
Sir, I think it's x plus y is equal to A.
Yeah, so this is x plus y is equal to A. Why?
Because z equal to 0 is the the plane, xy plane.
Yeah, because when you project this in the xy plane, this z becomes 0. So z becomes 0. That means this equation, in this equation, you put z is equal to 0. So you get x plus y is equal to A. So this line is x plus y is equal to A. So that is why you see the points J0A and A0. And how about this line? This is this is
z equal to 0 and y equal to 0.
Yeah, z is equal to 0 and y is equal to 0. So which is this line is y is equal to 0 in the xy plane. This is y is equal to 0. And this line? Yes?
This will be x equal to 0 and y equal to 0.
X is equal to 0, y is equal to 0. In the xy plane, this is no, z is equal to 0.
Z equals to 0 and x equals to 0.
Yeah, so this is x is equal to 0 in the xy plane. So you have this triangle. Okay? Now what is, so we have done the first step. We plotted the region D of integration, which is in picture 39. And we have also plotted the projection of this region in the xy plane, which is figure 40. Right? Now what is the second step? Second step is to identify the range of Z. So how do we do this? We take a point. We take a point in the projected region. So let us say this is the point in the projected region. And then you draw a line parallel to z-axis. This is the line, not that much parallel to z-axis. Okay, let me redraw it. This is the point I have picked in the projected region, and then I draw a line parallel to z-axis. Still not that parallel, but you imagine that this is parallel. Just in your mind, imagine that this is parallel. Now identify where this will enter this region of integration, this domain D. Where will this enter?
Z is equals to 0.
Yeah, very good. Z is equal to 0. And where this will exit?
A minus x minus y.
Yeah, it will exit on this surface. On this surface, it is exiting on this surface. So this surface is constructed with the help of this one, x plus y plus z is equal to a. So from here, if you solve this, you get z is equal to a minus y minus x. So you have a minus y minus x. This is the limit of z. And then after that, your work is simplified because now you move to this double integral. Okay, this is the double integral over the region R, and this region R is this projection. ठीक है? तो अब इसका कैसे आइडेंटिफाई करेंगे एक्स वाई? So this will be equal to, who is going to explain?
तो लाइन ड्रॉ कर देंगे या तो एक्स एक्सिस के पैरेलल या तो वाई एक्सिस के पैरेलल।
चलो वाई के पैरेलल लाइन ड्रॉ कर दिए, बताते जाओ, डिक्टेट करते जाओ मुझे, मैं
इट इज फ्रॉम x इक्वल टू 0 टू x इक्वल टू 0 टू a माइनस x।
x कहाँ से आ गया? y के पैरेलल ड्रॉ किया है।
x is equal to a minus
ओके
y.
सॉरी
Y is equals to 0.
Y is equals to 0 to a minus y.
a minus y
is equal to
a minus x
A minus
a minus x।
a minus x, और फिर x का रेंज क्या होगा? इसको इधर ले जाओ, कहाँ पे एग्जिट करेगा?
0 to a.
0 पे एग्जिट करेगा, और राइट में ले जाएंगे तो कहाँ एग्जिट करेगा?
a
पे एग्जिट करेगा। तो ये इसका इंटीग्रल हो गया। तो यहाँ पे था एक्स स्क्वायर था ना इंटीग्रेशन, पहला इंटीग्रल हो गया z के रेस्पेक्ट में, दूसरा इंटीग्रल हो गया y के रेस्पेक्ट में, तीसरा इंटीग्रल हो गया x के रेस्पेक्ट में। ठीक है, सो इसको तुम अगर कैलकुलेट करोगे तो तुम्हें आंसर मिल जाएगा। सो ऑल दीज स्टेप्स आर explained here. Is it fine?
Yes, sir.
So I think time is already over. So I'll stop here. But if you have any question, you can ask me. तुम्हारी लास्ट क्लास कब तक है?
So 25th
25th of
February.
ओह, तो बहुत कम क्लासेस लेक्चर्स हैं फिर तो। हमारा तो 1-2 लेक्चर मुझे एक्स्ट्रा लेना पड़ेगा। 25th February to the 7th, not even 12 lectures. Okay, so if you have no more question, then we can close the session.
$28. That's all related to the accuracy. So you are from the engineering physics batch, right?
This is a combined group of engineering physics and BSMS physics.
Okay, I see. So you are at campus or at home now?
Unfortunately, at home, sir.
I see. Okay. So yeah, so let's get started. So okay, so I see you can hear my voice. So let's start by start recording. Can you see the screen?
Yes, sir.
Great.
Yes, sir.
So let me make it full screen and see. Full screen presentation. Full screen what? Okay. So my name is Shilaritya Sengupta. I'm a faculty in the Department of Physics. So in this course, you are so I do research in condensed matter physics. So I'm going to talk about condensed matter physics and a little in particular about the area where I do research, the area I'm more familiar with, which is the soft condensed matter physics. So we are going to talk about it more. So basically in this course, so what have you what has been done in this course so far? Can anyone sort of give a quick summary?
So may I?
Go ahead.
Yeah. So we've not been taught in depth about anything, but various faculties have come and they've made us familiar with their respective field of research,
Hmm.
be it spintronics, quantum computing, etc., etc. And there was one week where we learnt about the lab facilities and everything about about our institution. That's it. That was pretty much it.
I see. So can you sort of, Ayush, can you give a sort of a list of topics that you have sort of got an exposure so far, learned about?
I don't have a list as such,
Just
but I can
whatever you remember, don't have to.
uh, I remember studying about color science and photonics.
Hmm.
Then I remember studying about spintronics,
Hmm.
quantum computing,
Hmm.
a little bit of quantum optics, and
Hmm.
that's pretty much it, I guess. There were more, definitely. It's
Hmm.
just that it's difficult
Hmm.
recalling them.
Okay. So I saw that Tanmay raised hand. So Tanmay, would you like to add something? Like to say?
Sir, some more topics that we studied were like laser cooling of atoms
Hmm.
and superconductivity.
Hmm.
Yeah, but
And
laser cooling of atoms comes under the photonics part. That
Hmm.
was taken by
yeah, you could say
Yeah,
that.
that's fine. So
Ajay Vas.
I mean, doesn't
That
I
was
mean,
taken.
you don't
And
have to worry
atmospheric
about much
physics also.
classification. Just wanted to know about the topics you have heard so far. So laser cooling of atoms and carry on, Tanmay.
Atmospheric physics and a little in brief about semiconductors.
Hmm. I see. Okay, so basically, so the idea of this course is to sort of give you some exposure. So this is a light course, meaning you are not going to study anything in depth, for which you will start to do from next semester onwards. But it's just to give you a exposure about what the physics. So you have heard about, you have all of you have read about physics, studied physics in high school and for preparing IIT joint. But now you are going to get a kind of paradigm shift, which means now the focus will be on real life problems and their real life applications. Because you are going to get a degree, like professional degree. So so this is the paradigm shift when you come to college and like the way you study. So the idea of this course is to sort of give you a kind of first-hand experience of flavor exposure. And so evidently different faculties, so they have different ways and perspectives about the subject. So we will get to know different viewpoints, and hopefully some of the topics you will like and you wanted to explore further during your time here. So that is the idea. So let me start with a brief outline of what I have for this week. So I will start with I will give introduction to the subject, and this introduction will be somewhat personal in the sense the way I see the subject. And so I will start with broadly speaking physics, and then I will so it will be done in a layer of specialization. Then I will zoom into condensed matter physics, and then I will further zoom into what is called soft condensed matter physics. And I also wanted to say a little bit about career opportunities. I mean, there is a placement section, as you all know, in IIT, so you will get to know a lot about that during your stay here for many times. So I'm trying to give you something which you may not hear from the placement section or from your seniors, but some gap or something in that I feel exists. So I'll try to give you some idea about some sort of opportunities. And so this first two is something that I'm aiming to cover today. And Friday I will have some little bit more in-depth introduction to soft condensed matter. So this is the plan. So let me go to the whiteboard. Can you see the whiteboard?
Yes, sir.
Yes, sir.
Okay, so let's start at a very kind of basic thing. So let's start with some, when you study physics in your high school, you always start with mechanics and units of physical quantities. So let us start with the fundamental physical quantities. So let's start with mass. So, and we are going to use SI unit. So today is 7. Okay, so let's start with mass. So SI unit is kg. So suppose if I ask you that what is the smallest amount of mass? Let's say if we consider an experiment, I am going to put a different amount of block on your hand. So what is the lightest mass that you can feel without doing any measurement? Is it like 1 kg? Meaning, so what I'm trying to say is that, let's say, can you so if I put you blindfold and then put a block of, let's say, 1 kg and 100 gram, can you sort of differentiate? Can you feel the difference?
Yes, sir.
How about 100 gram and 10 gram?
Yes, sir, we should.
Yes, sir.
How about 10 gram and 1 gram?
Still,
Yes, sir, we still be able to.
So Kunal is very confident that yes. Okay. How about 1 gram and 0.1 gram?
Sir, no, not much difference.
So not much difference. So let's say, so can you feel like 1 milligram?
So that's the point. We won't be let alone the difference. I'm not talking about the difference. The individual quantity of 1 milligram on our hand we won't be able to feel as much. I think
Okay.
that
Fine.
there won't be much force on our hand to detect it that there's something on our hand. I
Okay,
feel.
fine. So let's say we put, so we conclude that let's say about between 1 to 1.1 milligram. So let's put a number, let's say, so this is all unit of kg. So let's say 0.1 milligram, which is like, some of you could be like with practice may enhance your sensitivity and can differentiate, let's say 1 and less than 1. But let's say 0.1 is the absolute limit. Now let's go to the heavier end. So what is the maximum mass that you can sort of feel? Meaning, let's say, can you differentiate between 1 kg and let's say 10 kg?
Yes, sir. Yes, sir.
Definitely, sir.
10 and 100?
Definitely.
Yes,
Yes,
sir.
How about 100 and 1 ton?
so differentiate, we won't be able to hold it.
Yes, that. I mean, the other way we can do is we can keep it and try to push it. So that way we might be able to differentiate that the lighter one might just move a little and the heavier one won't.
Right. So this is how we do it. And then we sort of, if it's something, the mass is more than 100 kg, then it is difficult to push. And note
Yes,
that
pretty much.
why that we sort of limit is 100 kg, because can you guess why 100 and why not 10?
So I didn't get your question, sir.
So the point is that, as you said, that you can do this experiment that you push the object, and let's say if we are able to push it, we can feel the difference between the mass. And let's say we can easily push a 1 kg object, 10 kg object, and maybe up to 100 kg. But more than that, it will be very difficult. So why we stop at 100 and not 10?
It is compatible with our body mass.
Exactly, it is comparable with our body mass. So our human body mass is of the order of 10 kg. Yeah, so someone mentioned that I first should not see the name, that average person can't lift 100 kg. So I'm not talking about exactly 100 kg. I'm just trying to give a so at the moment I'm just talking about the order of magnitude. So 100 kg could mean 50 kg or something. And so if you and we are talking about let's say what is the limit, extreme limit. So in that sense, we can sort of we are focusing on the record, the world record. Okay, so that means that roughly speaking, that this is a range that we can call it a human scale. So when we talk about human, we are sort of talking about the whole population of the world and the extreme record kind of. Now, from your knowledge of physics, now can you tell me what is the smallest mass that you know of some object?
Mass of electron, I think.
Mass of electron, good. And how much is it?
9.1 into
1
10
AMU.
31 kgs.
Okay, so good that someone actually remembers numbers. So at the moment, I am putting a order of magnitude which is roughly, let's say, 10 to the power minus 30 kilogram. So this is electron mass. So what will be the other limit? So what is the most massive object that you can think of?
Sun.
Sun.
So black holes. Supermassive black hole.
So I heard sun.
Okay, galaxies. Galaxies.
Supermassive black hole, galaxy, and
universe.
Someone mentioned universe. Yeah, so that should be, think about it, that should be the answer, because all the other things you mentioned are all member of the universe and there are more. So the mass of the known universe this is the most massive object that we know today. And I'm just going to put some value for this. So I'm not going to explain how I get. I just, let's say we got it from Wikipedia. So this is like, this is the number. We cannot care. I mean, we don't have any idea how big is the number, but someone has estimated. Let's say we can count the number of stars that we have an estimate, and then we know the mass of like different stars, and then you can multiply and get that number. So let's go to our next quantity, which is length, another fundamental quantity. Again, same question. So what is the smallest length you can distinguish?
One millimeter.
1 millimeter.
So like without any equipments and stuff?
Without any equipment and stuff.
Yeah, so difference between a centimeter and a millimeter.
Difference between centimeter and millimeter, we can all understand. Yes. And what else?
So below a millimeter.
How about millimeter and less than a millimeter, sub-millimeter range?
Sir, after a millimeter, it's difficult for for a naked eye to distinguish. We'll need special equipments, screw gauge, vernier calipers, etc., etc.
Hmm. So can you see something that with, let's say, thickness or size which is sub-millimeter with our naked eye? What is the thinnest object you can see? We can see with our naked eye.
Here.
A single hair, fine. But anything? Can you see anything? But there is something that is even thinner. Which particle? So spider web, some dust particle. Okay, I will give you two examples. So spider web and hair is something like same order of magnitude. So I'll give you two examples which are much less in order of magnitude compared to hair. The first example is soap bubble. So this soap bubble, the wall of soap bubble is much thinner than it's at least 100 times thinner than hair. And the second example is if you close your eye, sometimes you see some particles floating. So those particles, I am sure that all of you understand what I mean. You will sometimes you see that so those particles are actually dead cells that are in the eye, on the lens. And those dead cells are also much smaller than the size of let's say, I mean, they're all sub-millimeter and at least 10 to 100 times smaller than that. But let's say 1 millimeter or something we can sort of put. Now, what is the largest distance we can sort of feel or differentiate? Let's say, can you differentiate between, let's say, 1 kilometer and 10 kilometer?
Yes, sir.
How about 10 and 100?
I guess gigaparsec.
No, with our naked eye.
So it depends on how we perceive, right?
Yes, so how we're looking at it, because even differentiating between a kilometer and 10 kilometers standing from a point can be
Closer.
difficult.
If we are traveling, we can figure it out.
Let's say you are
Yes,
sort of
but
standing on a hilltop where you can see, or in some hilltop, and in front of you can see sea.
yes, sir, in
Ocean
that
and
way
nets.
we can in that way we can differentiate between a kilometer and 10 kilometer. But
With 10 and
even from a mountaintop, a difference between 10 kilometers and 100 kilometer will be difficult, I believe. But I'm not sure because I have not tried this ever. So, but
Try
I
it
feel that it will be
Try it
difficult.
yourself and be sure.
It kind of depends.
Okay, so let's be conservative and put, let's say, 1 kilometer as our scale. That's something we can all safely do it. And we can also put it a little bit more, let's say 1 order of magnitude more, and maybe 1 order of magnitude just to extend it to sort of world records scale. Now, again, the question is that what is the smallest length or smallest size of something that you know?
I think it was the Planck's length mentioned in the Avengers.
Planck length. Okay. Someone said Planck length. So do you know what is a Planck length?
Yes, sir. We gravitational constant, Planck's constant, and all this, and we try to get the unit.
So have you studied it in your plus 2, or it's something that you have studied on your own?
Sir, I have seen it in the Avengers.
Own, sir.
In where?
In a movie.
Which movie?
It was a reference only. In the Avengers.
Yeah, what's the name of the movie?
Endgame.
One pager banana.
Okay, I didn't get the name, but okay, interesting. Yeah, so Planck length, but okay, so let's put it as Planck length. And do you know the value of Planck length in, let's say, a unit? Okay, let me put it. So the value is about 10 to the, we will come to it. So this Planck length We're going to discuss it in a moment. So this is the the simple definition is that this is the smallest length which we can probe in principle using the known laws of physics. And then on the other side, what is the largest length that you can think of?
The length of the universe.
Diameter of the
93
observer.
billion
Yeah,
light
so you can
years.
say that it is about the radius or size of the universe, of the known universe. So there are some fascinating videos on YouTube which explores this universe and its boundaries. So it's highly recommended. I will try to put some link later. So please take a look. So this again, I'm going to put some number which without saying how to calculate it, it's not relevant. Something like 10 to the power 26 meter. This is the boundary of the known universe. So then our final quantity is, or third quantity is time. Again, the question is why? What is the smallest time we can time difference we can feel?
Some millisecond.
Millisecond. Good. Some millisecond.
Sir, I think
So half
So there is something called persistence of vision. So basically, let's say to give you an example, so you know that the fan, the ceiling fan, it has 3 or 4 blades. So when it is at rest, we can see the blades clearly. So it's a distinct thing. But when it is rotating,
So the 1/16th of a second is what you're talking about, right?
okay, yeah. So there is some resolution. So if something moves faster than if the time, so basically something like our eye has a certain resolution there, so there's a minimum limit which is called persistence of limit. If you see two pictures within that less in the time gap which is smaller than that basic limit, which is about 10 to the power -1 or 1/16 something, then we cannot distinguish them as a separate image, and that is the principle of the movie that so the movie you basically see still images, but they are kind of a slideshow going on, and the rate is very fast. The frame per second rate is very faster than the persistence of vision. Okay, and then let's say what is the largest time scale we can feel or distinguish. So we can clearly know the difference between 1 second and 1 minute, and 1 minute and 1 hour. 1 hour and 1 day. How about what is the largest you can think? Think.
We can actually feel the lifespan of a human, I think.
Or lifetime.
So one lifetime.
But can you can you feel the difference between, let's say, 1 year and 10 years?
Yes, sir.
Really? Okay. How about 10 year and 100 year?
Yes, sir.
We will be able to once
no one will
we
be able to live 100 years. So differentiating between them will be difficult.
You can feel it different. You can understand the difference between 100 years. Okay, fine. So how 100 years is how much? How many seconds? How do you estimate it?
Sir, 1 year is, I think, 86,400 seconds. If I'm
That's
not
one
wrong.
day.
One day.
That's 1 day.
Yeah, 1 day.
That's 1 day.
So multiply.
So let's say we can do it this way. We can, let's say, we round it up to 10 to the power 5. That is 1 day, and into, let's say, 365 days. 1 year.
I calculated it's 3.156 into 10 raised to the power 9.
10 raised to the power 9. So I'm a little bit. I wanted to be a little bit conservative. So I want to put it as, let's say, 1 order of magnitude less. So 10 to the 8 seconds. So this is something, let's say, we can feel the difference. Okay, so then the question is again, what is the minimum possible lowest end of the spectrum? So there is a minimum time difference that you can think of. of any process.
So 10 raised to the power minus 42 seconds.
What is that?
The time taken by the universe to expand at the time of Big Bang.
So Planck time?
Yeah, so I would, okay, so I'm going to write it as Planck time because this is the theoretical lower bound. And
Yes, sir, but if you're talking about us feeling the difference,
no,
then it
this
will
is
be
not
the
us feeling.
persistence
This is
of.
the what is possible in the universe.
Oh, okay, fair.
So us feeling is this range. So again, so this is the thing that so this is the smallest time interval that we can probe in theory by the known laws of physics. And then as a higher end, what is the kind of biggest time that we know?
For an amoeba to cover the whole universe.
No, even probably that's not possible.
13.8 billion.
So yes, something someone said. So Jyotsna was
13.8
telling. What is that?
years.
What is that?
Age of universe.
Yeah.
Age of universe. Yeah. Age of universe. So age of universe. And
But
I'm just going to put some
in the age of universe, like
13.8 billion years.
Okay, so I'm just going to put some number and you can estimate it later. So in seconds, these are all seconds. Now let's take another quantity, which is the, let's say, speed. So what is the, let's say I give you some typical speed, and let's say you tell me what are the ranges. So for example, let's say a speed of a amoeba, or let's say snail. What is a typical speed of an snail?
One centimeter per second.
1 centimeter per second. It's probably less than that. It's probably at least 1 order of magnitude less than that.
Yes.
1 millimeter.
Probably something like 10 millimeter per second. What's the speed of a human when walking?
8 to 10 kilometer per hour.
8 to 10 kilometers per hour walking. So this is kind of, I would say, probably the world record. Even then 10 kilometer, probably world record.
0.1 meter per second, like that.
Okay, so in typically, let's say on an average, an average person, let's say, can cover at least 4 to 5 kilometer in 1 hour. So that means if someone is like athletes, they can probably do it like 8 kilometer on 1 hour, and you can convert it into seconds. What about running?
Sir, that will be for an average human will be around 10 to 10.
An average human can run at a speed of at least 15 to 25 kilometer per hour.
Sir, while running, we are applying 3.5 times more force on average.
I see. So when you, let's say, if you are running on a treadmill, some of you who goes to gym, if you're running on a treadmill, you can easily go to 15 kilometer per hour. And if you go to the world record speed, it will be probably 35 to 40 kilometer per hour. Now, in sport, let's say, so what's the typical speed of a cricket, the fastest speed of a cricket ball?
I guess up to it is 160 kilometers.
160 kilometer per hour. Okay. So in any sport, is there any that flies faster than all the sports combined?
So we
Sir,
didn't
please.
get you, sir.
Sir, please,
We
can
didn't
you?
get you, so there was a background noise.
So the question is that is there a speed of an object which is moves faster than a cricket ball? Can you give an example from any sport?
Baseball.
So the fastest object that I know of that travels from a sport is the badminton cock when you smash it. So the world record is probably 400 km/h. So this is probably faster than a baseball. So the basic point, the reason I put all these things is that, so this is our human scale. And this one is the operating range of the full universe. That we know, at least today. And you can see that the operating range of the full universe is actually huge. And out of that is a very tiny window is what is a human scale. So there are two things I want to say here. First thing is that, so this operating range of the full universe is what is called the scope of physics. So this is what you can study in physics. This is the range which this subject of physics deals with. This is the full range. And as you can see that it's a vast amount of subject. So obviously there is going to be different subjects. If you want to really understand anything, you have to divide it and then understand something about it. So we're going to coming to that in a moment. And the other question that one can ask is that why the human scale is in the range it is. So why this particular window? I mean, why this window is so this particular window? So anyway, so this second question is related to. So basically, this window, this is a deep question, and not only its answer is not fully known, but physics offers some idea to understand this. And one of the things that at the moment we can say that this scale, length scale, the human scale, it sort of defines what you call the day-to-day life experience. And this day-to-day life experience that means different objects that we see around us, different natural phenomena that occurs around us, and this is the subject of condensed matter physics. And this question, so the answer that comes from the basic subject that attempts to answer this question is statistical physics. Let's call it mechanics. So this is the two subject we are going to talk about, because this is where this is my area of research. So this is what we are going to talk about in more detail in this week. So let's go back to the okay. So I forgot to tell you one thing. So let us define these Planck constants. So we have these three. So this is, so I'm sort of setting it as a kind of an exercise for you. This is irritating. So you know that there is this H cross, which is the Planck. So these are fundamental constant. or universal physical constant, which means that these are constants. It doesn't depend on anything. It doesn't depend on energy, temperature, magnetic field, electric field, nothing. It's they are constant, and as far as we know, they are constant everywhere in the known universe, not only on Earth but everywhere. And take these three particular constants. So this is the Planck reduced Planck length. Sorry, Planck constant. And this is the speed of light. And this is the Newton's gravitational constant. Now the question is, what is the dimension of Planck's constant? Anyone?
So Joule second.
It's a Joule second. So this is a dimension of angular momentum, and this dimension, in terms of the fundamental mass, length, and scale units, is this. This is you can see that this is Joule second. And similarly, the dimension is a dimension of velocity, and this the gravitational constant. Its dimension is so you can work it out from the Newton's law of gravitation. Now the question is that using these three constants, one can define a length, and this length is called the Planck length. So from this combination, so make a combination of this H cross C and G, and that combination is called Planck length. And people have shown that this is, so this value, if you plug in these values of H cross C and G, so I'm going, so so this is what so make the combination out of this, which is a length dimension of length. So I'm not going to write down the answer, but this value turns out to be of the order of 10 to the power minus 35 meter if you, when you plug in the measured values, known values of H cross C and G. And similarly, you can measure a time, and so you see these are made of ml and t, so you can sort of invert it and express ml and t in terms of H cross C and G. So this is, and then there is something called Planck time, and this has a value of the order of, if when you will come out to be this. And for completeness, I also mention about Planck mass. So Planck mass, and this has a dimension which is very large. Some I forgot it, but something like 10 to the power 40 kg or something. So this the interpretation of this is slightly complicated. So this is basically, the interpretation is simple. This is the smallest length we can probe using the known laws of physics. And this is the smallest time interval that we can probe using the, so this, when I say probe, I mean we do not have any experimental device to measure this length at the moment, but this is the theoretical limit. Similarly, this is the theoretical limit. So there is no clock which can measure this interval. This is a theoretical limit. And so this is the homework to calculate this quantity in terms of H cross C and G. Okay, so now let me go back to our next thing. So now I want to tell you about the introduction to the, so this is the scope of the physics. So this is same everywhere. I mean everywhere in the universe, where whenever there is an engineering physics course in any planet, they are going to study this subject. Let us focus on our planet and your particular curriculum. So before coming to that, so let me tell you that from the research point of view, so there were in the at least in the 20th century, the driving force behind physics research, if you think about in the different directions it went, so you can sort of summarize it in terms of three basic questions. So these are like what when I say driving force, I am talking about like curiosity driven research, like the basic science research, not the application oriented research. So the application oriented research were mostly driven by two things. One is war or military, and the other was solving food problem. So this is like basic curiosity driven research. So the first question is that what is the universe made of? So what are the different structure of matter? So different things that we see around us, what is it made of? And this is the atomic theory, atomic hypothesis. And here I'm showing you a list to sort of kind of a history, so to give you a flavor of history. That so what I'm showing you is the different Nobel Prizes that are awarded, which are related to this theme. And you can see there are plenty of them. And these so these red ones are something that is there in the BTech first year lab, so you can do those experiments yourself. And so basically people started with sort of discovering the fundamental particles like electrons and etc. And then it was what was, there's a famous book which is called Inward Bound by Abraham Pais. And so this trend is like going to the smaller and smaller length scale, probing smaller and smaller length scale. So first people discovered about the atoms, like experimentally discovered atoms. So and then they went smaller. So they then went to the nuclear physics, which is the nucleus and the different protons and neutrons, etc. And they went even smaller, and so you can see about elementary particles, and this is called what is called the particle physics. And then when you go smaller and smaller, it's also so this is related to you can convert the length into energy, and people trying to probe higher and higher energy scale. And so you discover more heavier and heavier elementary particles. So this is the history of development of atomic physics to nuclear physics to particle physics and so on. And so these are the and this actually the end product at the moment is what we call the standard model of matter or of the universe. So this is something that you this is the subject of particle physics or what is called high energy physics. And you can see that some of these are like fundamental experiments, and some of these Nobel Prize are for developing different technologies like this cathode ray tube or X-ray diffraction or this particle accelerator, etc. So there are two kinds of work that got Nobel Prize. Second question is, so this is about what is matter, what is the structure of matter. The next question was, what is light? So we see light, I mean we don't see light, but we can see everything around us because we can sense light. So what is light? And you know about Maxwell's laws of electromagnetism, right? So have you read about Maxwell's laws?
Sir, we have not understood all those equations yet.
Okay, so maybe next semester you will take a course on electromagnetic theory, so you'll learn more about that there. But this is where so the point is that you know that so this light is electromagnetic radiation. So the question you can generalize it, when I say light, I mean light can have different frequencies, and we can sense the visible light is a tiny fraction of the frequency, but there are other kinds of radiation like X-rays, gamma rays, and radio waves, FM waves, terahertz waves, and short waves, and it's whatnot, heat waves, infrared, ultraviolet. So these are all like same thing, electromagnetic radiation under different frequency. So what is this made of? And here there are a lot of I mean, these are some of the example of Nobel Prize that were given in this particular case, this particular theme. And as you can see that some of these Nobel Prize are for discovering theory and answering the theoretical questions like this Planck's quantum theory. And some of these other things are to discover the technologies like this microscope or holography or the laser, etc. Optical fiber. And the third question is obviously that so you divide the universe into two parts. One is the matter and one is the electromagnetic radiation. And your quantum mechanics says that at the fundamental level, so the particles like massive particles like electrons and elementary particles that compose matter, and the elementary particle of light, that is photon, so they behave in the same way. But for our purpose of studying, we divide the universe. We may divide the universe into two parts, and then you can ask that how does matter and light interact with each other. So this is what is important, because this is how we understand different properties of matter. So we shine light, which means, let's say, if you want to do the structure, when you go to, let's say, if you want to know that whether your bone is broken, so you go to do an X-ray. So basically, that means you are applying this. So you want to know about the structure of your skeleton, whether there is a bone broken or something, and you are passing. So you are using the interaction between X-ray and your bone to get the answer. So this is matter and interaction between matter and light. And this is very important. Whole of condensed matter actually uses this studies this interaction between matter and light. So to understand different properties of matter. So we are coming to that in a little bit more detail quickly. Okay, so now before going further, I just wanted to mention one quick thing that, so I mentioned this fundamental constants. So we can actually use these fundamental constants to sort of separate different theories of physics under different regime. So these three different regimes are based on this. One is the speed. So it's a very curious thing that we have different theories of physics that to explain, understand these three questions. Like you have, for example, if you want to study how things move, you study mechanics, and mechanics has different. The laws of mechanics turns out to be slightly different depending on, there is classical mechanics, which is the Newtonian mechanics, Newton's laws, and there are quantum mechanics, which are Schrödinger equation. So the laws are different. So it depends on different regime. And some of you must have heard about relativity theory. So that is also a different regime. So these three different theories. So how you can use the same constants to identify this regime. So let's say one axis, there's h, and this is a very simple kind of just abstraction. So basically, you say that if quantum effect h represents quantum effect, and let's say we have only two values, h is 1, which means quantum effect is important, and h is 0, which means quantum effect you can ignore. Similarly, the c represents the typical speed of the process. So 1 by c is 1, means the speed at which different things are moving are comparable to speed of light. So that is called a relativistic regime. And if the different things move, like our day-to-day like cars and planes, etc., they move at a speed much less compared to the speed of light. So we can set for 1 by c to be 0, which means c is effectively infinity. So that is a non-relativistic regime. And g is 1 means the gravitational force is very strong. And g is 0 means you can ignore gravitational force. So this is the simplest simplification. So g is not really 0, but compared to other kinds of forces, which means let's say electrostatic forces, you can ignore gravity, and simple way, so it's a kind of an artificial way to say that by saying we are setting G to be 0. So am I able to clear this? And so then using this construct, these three different axes, all the known theories that we know, we are basically you can arrange on a cube. So this origin is where all the three constants are 0, which means you are ignoring the quantum effects, you are ignoring the gravity is not strong. I mean, compared to electric force, gravity is you are ignoring gravity. And the objects you are studying moves much slower than speed of light. So this is the day-to-day life, the classical mechanics or the Newtonian mechanics, non-relativistic Newtonian mechanics. So this is what we use when you solve mechanics problems, Newton's laws. And then you have studied a little bit of quantum mechanics, where you are now going to the, let's say, atomic scale or something, where you are studying using the so you are studying quantum effects. But remember that when you are going from here to here, you are still doing it in the non-relativistic limit, which means that whatever objects you are studying, they are moving much slower compared to speed of light. And so these are the two regime you have studied so far in your physics, high school physics, different subjects. The other regimes are covered in different courses in physics, your undergraduate and master's level, and like your BSc and MSc, and then let's say in the more advanced courses. So some of them you can take. I mean, you will get exposure to some of them. So this construction is called physics cube. So where you represent all the known laws of physics as different regime. Okay, but let's come to your curriculum, that either whether you are in engineering physics or you are in BSMS course. So there are some of the things that are common in this you are going to see, and some of the things will be, most of the time the point of view are different, but sometimes you will take common courses and sometimes you will take some specializations which are different. Now this curriculum, I hope you have all seen what is you have gone through your syllabus and prospectus, etc. So, and again, this is a personal way of organizing your curriculum. So I find it kind of simple because I work on theory, so I look at it from the theory point of view. So there are basically, let's say you can divide the subjects. I mean, when I say subjects, it is like full curriculum, full syllabus. So there are certain fundamental subjects where, so there are first of all two differences. One is that you study experiments, which is practicals, and these experiments are very important because physics is actually an experimental subject. So no matter how good is your theory, if it doesn't match with experiment, it is wrong and you should modify it. So this is the first rule of physics, first law of physics. But then theory subjects, so so there are certain topics that you sort of going to learn or you should know. So these topics are basically so these topics actually tell you about the laws, basic fundamental laws of physics. So the first topic is that this force electromagnetic theory, which tells about the electrical force laws. So maybe next semester you're going to learn about it. Then there are these mechanics, how things move, and classical mechanics and quantum mechanics. So depending, the rules are different about particles, how move, whether they are classical particle or quantum particle. And the statistical mechanics, which is a probabilistic description of how things move, and thermodynamics. So these four subjects, it also sort of together they cover all the rules that physics knows about how things move. And then there is another thing which is the mathematical physics, because physics is all the books, you know that they are written in the laws are described in the using the language of mathematics. And when I say mathematics nowadays, it also includes numerical, like computational physics, meaning coding and learning about coding, etc. So these are the theory subjects, and then everything else that you will find in your syllabus, we can sort of think of it as kind of application of these rules to study different aspects of the universe. So you learned about the fundamental rules here. So remember that we sort of, sorry. So in this picture, what is happening? So this is the entire range of the universe that you can study in physics. So you learn the basic rules from these courses and the experimental tools from your lab courses, and then you can study different regime of this. You can explore different regime of mass, length, and time, and that will give you different type of subject. So it could be, if you are talking about the real life phenomena, which is like mostly confined to this human scale, then this is condensed matter physics. It could be electronics, optics, nuclear physics, and so on. Okay, so I think the next thing is about condensed matter physics. So how am I doing with time? We have. So, okay, so maybe I will skip this part, and maybe I will talk about it next class. But let's say I wanted to tell something here about the, so let's say we are going to cover it next class. But
Good evening, everybody. Am I audible?
Yes, sir.
Okay. So still people are adding, so let us wait for them. We'll wait for 5 minutes and then we'll start. Good afternoon, everybody, and now we would start. I'm surprised how much time people need to get connected. It's 12 minutes past 17, and still we have barely 72, 73 people. So 1/4 of our class is getting spent in waiting for people, which is very disappointing. And so, I mean, we are also going beyond the prescribed time because I need time to complete my lecture. So I would appreciate if people join in time, at least on time. So we can wait for at least, I mean, at the most 5 minutes beyond the prescribed time limit. Then we cannot wait till 6:15 or 6:20. Okay, so should we start now?
Yes,
Yeah.
sir. We should.
I understand, Aro, some of the people extend their lectures, but then, I mean, this is really taxing for us because in that case we end up getting less time. And maybe not in this week, but next week onward, I might require both these classes. I mean, Monday as well as Friday, because we are left with so many topics, and now we don't have many classes left. So I'll need your cooperation for that. Okay, fine, friends. So whatever topics we have covered till now, I have uploaded their slides on MS Teams, so you can approach it there. Email etiquette I just uploaded today, and now we are going to talk about one of the menace of the modern day communication. And as internet users, all of us have been really struggling. And this is not typical of teenagers or people like you. This is also typical of people like us. Every day I come across such tempting headlines. And after going through these headlines, I realized that I have been duped or deceived. So there are so many fake sites that are just gaining by attracting our attention by posting these tantalizing or let's say tempting headlines. So this morning I came across a headline which says Jaya Bachchan discloses how Amitabh Bachchan and Aishwarya Rai live in their home. Now, this was written in such a way that, people would get alarmed as if Amitabh Bachchan and Aishwarya Rai have some, some kind of relationship other than the relationship of a Sasur and a Bahu. But then if you read this, you will come to know about something which is just opposite, in which it says that, Jaya Bachchan does not like to watch TV with her husband, so he watches it on Abhishek Bachchan, while Aishwarya is a good Bahu who takes care not only of her children but her Saas, Sasur and everybody. Likewise, you will come across lot of such, and they are very intelligent people actually. So they will throw such stuff which might, match with your interest area. Like I get lot of such stuff regarding cricket. So suddenly, and they will always leave it like this. Now this player is certain to go out of favor. Rohit Sharma has brought these players whom Virat Kohli disliked. And if you read the article, you will feel like killing the person who has penned it or who has shared it. Now, this is about the, proliferation. Proliferation, I guess, हिंदी में एक हम लोग कहते हैं कुकुरमुत्ते की तरह फैल जाना. कुकुरमुत्ता एक तरह का प्लांट होता है जो कहीं भी बेतहाशा फैलता है. उसको किसी तरह के खाद पानी की आवश्यकता नहीं होती है. तो if something spreads like a wildfire, we use this kind of phrase to define that. So the point I'm making is, such fake news, they spread like wildfire, and in fact they are not at all healthy for any civilized society. But then the thing is, given the immense potential of ICT, that is information and communication technology, now we have n number of sites, and out of them maybe 1 or 2% are verified sites, and 98% of sites are shady or fake. Now all of us are really struggling how to do away with these fake sites. So today we are going to talk about fake news as a means of communication, and obviously fake news does not have any authentic source or authentic information. Well, friends, during COVID times, we have seen lot of such fake news circulating. And, like we don't really know, but we have fallen prey to such fake news. Like many people posing as if they are, experts of COVID. They have been, sending all sorts of fake news, spreading them through social media sites, asking us to do something or do something else, which will save us from fake news. From COVID. In the first wave, we had also received many such videos in which somebody poses that I'm in China, I'm in Italy, I'm in the worst hit countries and this and that, and I have been confined to my room for the last 20 days or 30 days or something, and people have been falling like 9 pins outside my window. And I have discovered that, consuming or gulping or gargling with lukewarm water or something is a cure, a definite cure for this. Likewise, in social media, many people posing as doctors, questioning, critically analyzing, even questioning WHO, ICMR, and also trying to convince that these are the traps laid by the pharmaceutical companies to make a very heavy purse out of it. Well, I understand that many of these rumors may have somewhat of truth, but then it cannot be verified. Well, friends, we saw that even Ramdev ji proposed earlier that his coronal kit is capable of getting people cured from corona. And then there was, barrage of attacks on him simply because he was, accused of playing with the health of the people without having solid reason. And why not? We have seen that the corona vaccines that have been laid by WHO, they have followed a certain scientific, process in order to tell us exactly about their efficacy, about their composition, and they have told us how they have been prepared and how do they work. So some of them are, dead virus based, some of them are RNA based or DNA based and whatnot. And their efficiency has also been clearly spelled out that they are 70% efficient or 90% efficient and so on and so forth. And you see, we are convinced that we are using a right kind of vaccine. But then same is not true of, the other people, because they have either not tested their medicines. I understand that I'm not at all critical of our home remedies or our traditional herbal medicine. But then the thing is, the point I'm making is, unless and until there is solid reason and scientific, reasoning involved in any news, it turns out to be a fake news because it does not deliver what it promises. So friends, we are going to talk about fake news, which has been spoiling our time, precious time. We are afraid that this is also perverting and polluting our young minds. The young minds like you, they are very, very fertile and they need not be spoiled by such fake news because this will damage you forever. So let us build this discussion around fake news. What is fake news and why is it used? And if at all there is some kind of filter or remedy or some kind of awareness that can save us from spending our valuable time and resources on this. And if there can be in future some kind of technical filtration process, like in our mobile phones, like in our emails, we get these levels sometimes. Like in our institute email, we either spam is written or marketing is written or something is written. And this labeling tells us whether we need to open these emails or just let them go. Fine. So can we use this kind of filtration process or can we develop such filtration process where such fake sites are identified or such fake titles are identified and people are saved from getting into them. And one of the biggest problems is that such news items are very, very dangerous. Sometimes if you click them, maybe they will steal your data and they maybe they will post you or something. I mean, a lot of such things are happening. So that is why, and again, there are different motives, mostly hate speeches, pornographic material, political, labeling. Such things happen because of this fake news. And you will find that often than not, when you read the title, it looks very, very promising. When you read the content, you will find that the content is entirely different. Disappointment, a very strong sense of hate and irritation, and would feel like killing the person who has pinned down the title. So let us begin this discussion. So can you see my slide? Are my slides visible?
Yes, sir.
Yes, sir. Okay. So Abraham Lincoln, the celebrated American president who has given the most quoted definition of democracy by the people, of the people, for the people, he said, don't believe everything you read on the internet just because there is a picture with a quote next to it. Well, he said it long back, but friends, you can find it, still find it relevant, because you will find that there are a lot of people who are duping others by putting beautiful pictures, profile pictures or DPs, and making fake IDs. So internet is a very powerful, colorful medium, but that is also its, curse. Now, if we talk about fake news, what is this? It is important for the young generation to know about fake news so that they can make proper use of social media. Nowadays, when social media is taken to be authentic, and you often fight with each other based on your knowledge gained through social media, that yes, this thing is this and this thing is this, it is very important for you to exactly know whether your source is authentic and the knowledge that you have gained is authentic. So fake news is any article or video containing untrue information disguised as a credible news source. And while fake news is not unique to the internet, it has recently become a big problem in the digital. I mean, we always know that, nothing comes without its sidekicks. So every pill has its side effect. So based on that principle, every good thing has a shady side. Fine, and it comes for a price. So if we have developed internet for the wider dissemination of knowledge and information, and friends, the entire knowledge is at the click of a button away from us. Friends, the same platform has become a headache for us because this is being used for wrong reasons as well. So that is why this is so important for us to know. Well, friends, what happens, basically there's fake news sites. They use clickbaits. Now, what are these clickbaits? It's important for you. Please remember this term because this is central to our discussion of fake news. Now, clickbaits are phrases that are designed to attract the attention of a user who, upon clicking on the link, is directed to a web page whose content is considerably below their expectations. So you may be, tempted to go to that. Let's see. Rohit Sharma says, I'll see Virat Kohli now that I'm the captain. Now this sounds very tempting. What kind of statement has Virat Kohli, Rohit Sharma made? Are there any fissures that have surfaced? Has he said something very bold? Is it going to spoil Indian cricket? I mean, lot of possibilities, emerge in our, suddenly you will find the career of these two cricketers is going to be over. And then you are, interested in knowing. And then, you find that the article reads like this. Rohit Sharma has said that, Virat Kohli has always been a good friend and good mentor and has taken the team to the next level. Now that I have assumed captaincy, I look up to him to utilize his experience. So look at the title and look at the content. Likewise, Gavaskar says the career of these two players is over. Now you read the whole article and then you find that Gavaskar says that, if Rahane and Pujara continue to go through this kind of lean patch for another one series, their career is all but over. Now you will be certainly disappointed by the content. So these are clickbaits that are used and they are always, hiding more than they are disclosing. So these are called clickbaits. Okay. And for instance, you can look at this. A credible site would have a title such as Donald Trump wins the US presidential race with one single, this exclamation mark. But same item would be presented by a fake news site as with the help of a clickbait, such as guess what? Couple of question marks. Donald Trump is the next US president with lot of exclamation marks. So this is one of the ways you can find out whether it is fake news or a real news. The use of so many punctuations. In such a case, the tool would categorize the former, and so there are certain tools that have already been prepared, and based on their architecture, they identify prima facie that this kind of a title is fake and this kind of a title is genuine, and accordingly they ban those sites. One key characteristic of clickbaits is that they tend to lead readers to web pages containing information that is very different or hardly related to the information highlighted by the link, as I told you with the help of a couple of examples. And as a result, what happens? Majority of the users end up disappointed, leaving the sites as soon as they have visited it. And this results in high bounce. Now this bounce will also be another indicator for the technology. If the bounce rate of a particular web page is very high, the tool for identifying fake news will take it as an indicator and will ban such sites. Let's go ahead. So fake news in fashion background, there has been a rapid increase in the spread of fake news in the last decade. And we saw how this was used in the 2016 US elections and how beautifully the political parties have been using them. And we are living in an era of post-truth where, the media, whatever media projects and presents becomes the truth. And the political parties that are more advanced and more sophisticated are using such fake news. And the best use of these media platforms is being made by the parties that have the best media managers. So, a lot of people know that the media management of the current government is really very good. And that is the reason, in digital war, they have always dominated other parties, and that has really helped. So, but then it's not about using media platform, it's about creating a lot of fake news to keep the people guessing, to keep the people, confused. That is a concern, and I don't point fingers to anybody. This is being used by anybody. This may be used by companies for, gaining sales. This may be used by individuals for gaining popularity. This may be used by political parties for gaining power and support and whatnot. I mean, this may be used for a variety of purposes. This may be used by one nation against another nation. And this is being used very, very, prominently. And the terms that are, synonymous with this are propaganda, misinformation. So, I understand that, like when I was a student, I still remember during 89-90, I was also having one of the papers on advertising, salesmanship, and public relations. And in that, my teacher taught me how the Western media raises propaganda against the Southeast Asian nations or South Asian nations. So one of the examples he gave was that of BBC News. And he said that BBC News will always sensationalize and communalize any small, happening, scuffle, even if one Hindu and one Muslim have fought over building, laying their drains outside their house, then also BBC will enlarge it 10-15 times and will say India में आज जो है कम्युनलिस्ट वायलेंस हो गया. तो लोग इस तरह से प्रोपेगेंडा करते थे, जैसे यहाँ पे कहीं कुछ स्टैम्पिड होता है, 5 लोग मरते हैं, 50 बताते हैं. और हम लोगों में से लोग हमेशा इस बात को मानते हैं कि बीबीसी सबसे ऑथेंटिक है. अगर बीबीसी ने कहा है तो सही होगा और हमारा मीडिया सप्रेस कर रहा है. तो प्रोपेगेंडा इज नथिंग न्यू. पाकिस्तानी मीडिया does this kind of propaganda against India, and so I mean this is part of it, and misinformation is also given. जैसे अगर उनका 10 लोग मारा गया तो कहेंगे कि मेरे कोई हताहत नहीं हुआ. दूसरी तरफ अगर उन्होंने एक इंडियन सोल्जर को मारा हो तो कहेंगे कि हमने 10 को हताहत कर दिया है. So propaganda, misinformation, these are also part of fake news. And so basically they are categorized into 3 categories: misinformation, disinformation, and malinformation. So basically, misinformation is false connection or misleading content. Disinformation means false context, and we can also say imposter context or manipulated context or fabricated content. Now the thing is, the content is completely fabricated. There is no truth in that. And malinformation leaks, information leaks or harassment or hate speech, these are treated as malinformation. So these three are very, very important. Why is propaganda or misinformation or fake news awareness important? As I said, friends, this impacts the most vulnerable population. Now you can ask who are the most vulnerable population, and I can tell you our entire nation is vulnerable. Why? Because we are not media literate. Almost on a daily basis, I find it difficult to convince my wife regarding some of the things that she picks up from WhatsApp messages or Facebook or other such sites and always believes them to be true. And I try to make her understand, no, this may not be true. And she says, no, had it not been true, it could not have been shared by so many people. Now I have a tough time. But then the fact is, she is not the only one. Even I also fall prey sometimes to this fake news campaigns. As I mentioned, whenever there is something related to cricket, I'm always alerted and always attracted towards that, just to find that the information is misinformation and propaganda, nothing else. And this is done, because all of us know the people trying to get maximum clicks or maximum likes in order to gain from that, and they are getting paid because of that. So there is a healthy competition going on that if I make my news item attractive to look at, I mean, maybe I'll be getting paid because of the likes I'll be getting. So since information and communication technology is so central to the young lives nowadays, why it is important, as I said, we have the greatest number of vulnerable people, a sizable vulnerable population of teenagers who more than their textbooks rely on their mobile phones and media sites. As a result, what is happening? They believe more in the information given on these sites than their teachers themselves. So there is a period of crisis now. Teachers who talk about something with some kind of authority and solid information and based on their own experience and knowledge, now they are not taken to be authentic. Widely spread fake news, they are considered to be true. And then our country has a very low literacy rate. So a lot of media users are illiterate people, and whatever they see, whatever they receive, they take it to be true. There is no way they can really confirm whether the government has really done something, whether some welfare schemes have been what people have been talking about have been launched, where the claims that are being made about a particular monument being a former temple is really grounded in some kind of truth. Whether something is something, I mean, a lot of things, we don't really know what is true and what is not true. So the significant rise of fake news as propaganda in recent years makes it critical that students have the skills they need to identify truth and discern bias. And what is propaganda? A communication that attempts to influence community to agree or disagree with some cause or position. So nowadays the country is going to polls, especially I'm talking with reference to Uttarakhand. Our state is going to polls on 14th of February, the Valentine's Day. And so a lot of such thing is going on. And this tug of war, who is Sacha, who is Jhuta, who has done what, who has done nothing. I mean, there is always this kind of, the other day in media debate, they said that अमर जवान ज्योति का जो लॉ है वो बुझा दिया जाएगा. अब उस पे डिबेट हुआ जा रहा है और हम लोग जो आम जनता है वो सुनने के बाद ये सोचती है कि भाई अमर जवान ज्योति जो है इंडिया गेट पे, ये तो भारत का प्रतीक है और भारत के उन वीर सेनानियों का सम्मान है जिन्होंने अपने देश के लिए अपनी जान दी है. ऐसे में एक ऐसी सरकार जो खुद को राष्ट्रवादी बताती है, जो कहती है कि हमारे लिए राष्ट्र हित सर्वोपरि है, जो कहती है कि हमारे देश के जो प्रहरी हैं, जो रक्षक हैं, हम उनके साथ हमेशा खड़े हैं, उनके परिवार के साथ खड़े हैं, उसने ऐसा अटपटा निर्णय क्यों ले लिया होगा? तो जब वो देखने लगे तो पता चला कि नहीं भाई, उससे भी बड़ा मॉन्यूमेंट इन्होंने बनाया है, रेगुलर मॉन्यूमेंट बनाया है, और ये उसका उसमें विलय करने जा रहे हैं, न कि उसको बुझाने जा रहे हैं. और तब जाके ये समझ में आया कि इवन जो हमारे मीडिया हाउसेस हैं वो भी फेक न्यूज चलाते हैं ताकि उनकी टीआरपी बढ़े, और इसीलिए इस तरह के मिसलीडिंग कंटेंट वो डालते हैं, उस पर डिस्कशन कराते हैं, और बाद में लोगों को ये समझ में आता है कि नहीं भाई, ये ऐसा नहीं, ऐसा है. सो प्रोपेगेंडा ऑफ एनी फॉर्म इज नॉट गुड. Now, what is the importance of communication skills in the whole debate of fake news? So there is ability to respond critically to online propaganda, misinformation, and fake news is more than a safeguarding tool. And this is also an important democratic competence in its own right. So if we need to know about them, we need to develop what is critical thinking, and also need to develop what is said to be information literacy. And analytical and critical thinking and knowledge and critical understanding of the globalized world include the role of language and communication in a vital manner. So look at it, you consider the source, whether the source looks spurious or it looks authentic, and read beyond the line. Don't go by the outrageous headlines. Okay, and check the author who has claimed it. Does he have or does she have any authenticity? And also find out the supporting sources. Check the date of it, and you can also find out whether it is a joke or it is something serious, and look for the biases. We all know that media literacy also includes a certain degree of authenticity, a certain position of objectivity. Now the media houses are supposed to be objective, although I can tell you with my own understanding and experience that none of the media houses is completely objective. And the moment we tune in, we come to know whether it is pro BJP, pro Congress, pro left, or something, because all these media houses are, run by some people who have loyalty towards something. In the South, many of the media houses are owned by politicians and they act as their agents and their advertising agencies. So if Sun TV is talking about a particular politician who has been found guilty in some scam and is projecting her or him as innocent, not only innocent but a hero or a goddess, a faultless goddess, obviously you can understand that the intentions of the news agency are doubtful. You can also ask the experts whether this particular site is authentic or not, and why and how it has become such a big menace that all of us would like to know. So online searches for misinformation, disinformation and fake news at all-time high during COVID-19. And dear friends, I told you why, because everybody became an expert explaining the theory behind the spread of COVID-19 and everybody explaining lot of such remedies, homemade remedies for cure of COVID-19. So all of us turned experts, all of us suddenly became degree holders in medicine or Ayurveda, and all of us came up with our own explanations. So we found that the media or the media platforms or such messaging platforms like WhatsApp, they have been flooded with such fake news articles that are designed to outrage and shock, causing some readers to share it on Facebook, Twitter, or another type of social media platform without questioning it. We also came to know about a lot of fake news regarding two doctors dying after kissing each other, or something happening. So people were cooking all sorts of stories. And many of these stories were not true. Even the claims that were being made about the number of doctors and frontline workers succumbing to COVID-19, that was also questionable. So, a lot of such things have been going on. And although fake news has always been one of the biggest menace in the internet world, of late in the last 2 years, this has assumed such proportions that we really need to tackle this problem now. In the last few years, number of fake news stories have increased via social media platforms. WhatsApp is not a media platform; it's a messaging app. Facebook, YouTube, because they are shared online faster than we can ever imagine, and they are free, and so anybody can do that. And now that we have, all of us have the smartphones, anybody can do anything. There have been varied uses of the term fake news in different reporting of news. And during the second half of 2016, the term was searched tremendously by people, shown in a Google Trends map of, as I mentioned earlier, the US presidential polls, where fake news was used on a huge scale. And some people say that Trump became US president because of that. And now the question comes, if this is so toxic, so damaging, why do people write fake news? Well, friends, it's like asking a question. If all of us know that wars are not good for humanity, or the weapons are not good for humanity because they can only kill, they cannot be productive. So other than taking lives, they are serving in no way the human reasons, but still the countries have been spending their hard earned money on their coming up with these weapons, and they have millions of uh, dollars or rupees as budgets for this thing. So uh, writers of fake news typically created for one of the following reasons: to fulfill a social agenda like angering a population against a political opponent. So you will find that there are a lot of such extremist groups that create this kind of content or propagate this kind of content, and I have seen it on Facebook or on other platforms. People circulate such things that anger a certain people, and such things are fabricated so that political mileage can be taken. So suddenly we'll find that a video goes viral in which a Dalit young man is being beaten red and blue by a certain section of people, or you find that a person of a particular religion is caught with some some meat of something or something, and then this is or is found slaughtering something, and that is circulated amongst the people, and then people are angered, and that also helps them you know uh, you know you becoming one, and that whole thing is done with a view to polarize the votes or polarize the people based on their caste, creed, or something. So one of the reasons is a social agenda or political agenda, and or to earn advertising revenue. As I said, the number of likes, so number of clicks gives them advertising revenue, and that is why they come out with this. And unfortunately, this is resulting in a booming business, and a lot of people are tempted to do that. So what are the challenges? I mean, there are a lot of challenges. As I said, internet is free for all, and that is the reason anybody can create any kind of content and can easily circulate that. And there are no filters, or maybe we do not want to use filters. That is also one of the things. Sometimes we just wonder if consuming alcohol and chewing tobacco, or for that matter any drug, if that is so injurious to health, why do the governments allow their production? It's very interesting. You will always find that the governments continue to support them. So the first thing which Kejriwal gave a go-ahead when he was not able to contain the spread of COVID was to allow the wine shops to open. And immediately we found that things fell in place. It was interesting to see that, there were thousands of people in queue without mask, without social distancing, and there was no corona. And they were all struggling to find nectar so that they become immortal. और एक घूंट गया होगा और वो इमोर्टल हो गए होंगे. सब कोरोना वगैरह सब भाग गया होगा और गवर्नमेंट भी आराम से सो रही होगी. तो एक तरफ तो गवर्नमेंट की ये चिंता खत्म हो गई कि लोगों को दवाई प्रॉपर मिल गई और वो लोग अब स्वस्थ हो गए, और दूसरी तरफ गवर्नमेंट को इतना हाई रेवेन्यू मिल गया कि वो जितनी प्रॉब्लम थी कि हाँ भैया कैसे चलेगा, अभी तो बाजार बंद हो गया, अभी तो प्रोडक्शन बंद हो गया, तो उससे भी उनको मुक्ति मिल गई. तो सवाल ये है कि जब हम बात करते हैं फेक न्यूज़ की, तो ऐसी क्या मजबूरी है कि हम फेक न्यूज़ को कंटेन नहीं कर सकते, फेक न्यूज़ को चेक नहीं कर सकते? मुझे ऐसा लगता है कि हम चेक करना नहीं चाहते हैं, बिकॉज द सोशल मीडिया प्लेटफॉर्म्स आर gaining by that. They are gaining lot of users, they are gaining lot of content creators, although the contents are spurious, injurious, but then the people running these platforms are gaining, and that is why. So one of the challenges to me is convincing people, and this has never been possible. The entire humanity would turn divine if only we realize that we have to do away with everything that is harmful for humanity. But we can never do that. We have got it in bargain. So if God is there, Saturn is also there. If Ram is there, Ravan is also there. That means good and evil go hand in hand. So if these media platforms are boon for some people, they are bane for some people. So, the challenges are inherent. The moment you lay down some sites and some programs, the hackers are at work and they immediately decode the codes and hack these sites. And then again, when you come to know about their hacking, you develop anti-hacking software, and this process goes on. So there are a number of challenges facing schools wishing to take propaganda, misinformation, and fake news seriously as an education or social issue. The speed with which technology and young people's online activity changes makes it difficult to govern the young generation. And so, by the time you tell your young people that these are the sites that need not to be visited, need not to be trusted, already there are hundreds of such sites that have been visited by them. So that is why this is going to be a real challenge. Now comes the question, what do we do? I mean, we know that this fake news are going to harm the entire humanity, and they have been rather harming the young generation people as their very grooming is not proper, and they're falling prey to such spurious, untrusted, malicious news items, and their young minds are being filled with information which is not verifiable, which is not trustworthy, which is not true. The fact that there has been never ever a term like true news as opposed to fake news, because true or false, it depends on the ability of us, the credibility of us, and also our perception of a particular thing. but still, you know, there are certain things that can be verified. There are certain things that cannot be verified. Now, the question comes, we know that fake news is prevalent at a massive scale. What do we need to do in order to counter that? So there's certain things that we can do because people say charity begins at home. That means if we start it doing at our own individual levels, maybe we may be able to contain it to some extent, and then we can hope that in future more and more people will join the bandwagon, and then this will be contained to a limit that would be good for us. So to counter the effects of fake news, we need to set itself apart through increased vigilance to ensure it does not lend credibility to hoax stories. And for that, we need to check. And as I said in my second or third slide, like clickbaits, look at the clickbaits. If you find that a title of a news story is unusual with so many punctuations, so many exclamation marks or so many question marks, you need to understand that this is not authentic. And second thing, if you check the vital stats of such websites and you find that bounce back is, the extent of bounce back is quite high, then also you can find out that these sites are fake sites. Fine. The third thing is, whenever you come across anything, develop a critical sense, question it, use your understanding to counter it. So the moment somebody says that, I'm prescribing these 2 medicines and you will be cured of COVID, you need to understand the composition of these medicines. You also need to understand who has prescribed it. What is his degree? Is he a doctor? Does he, like in case of say Love Agarwal, we all know, makes statements on the behalf of Indian Health Ministry and is a secretary there. We know that a particular person is director of AIIMS Delhi, and he appears on national media and talks about something. We know about the General Secretary of WHO, who makes his appearance on international TV and talks about something. Now, when these people make some claims, obviously we got to believe them. But anybody claiming to be a doctor, anybody making stories, and I have seen many people, many such people, and they always bring some data which convinces us. एक आध डॉक्टर हमने देखा है जो आते हैं और कहते हैं कि साहब ये बताइए, इनको तो कोरोना नहीं हुआ, साहब मैं तो इतने सालों से ऐसे ही घूम रहा हूं, मुझे तो कोरोना नहीं हुआ, तो आप ये बताइए ये लोग क्या कर रहे हैं, ये तो पूरा का पूरा इसमें जो है स्कैम है, और हम उनको मान लें, हम उनकी तरफ बिना उसके चलना शुरू कर दें। तो ये जानना भी जरूरी है कि जिन लोगों की आप बात कर रहे हैं, जो लोग आपसे बात कर रहे हैं, वो कौन लोग हैं, उनकी डिग्री क्या है, वो क्या किसी हॉस्पिटल में काम करते हैं, उनका क्या किसी उसमें योगदान रहा है, किसी वैक्सीन के डेवलपमेंट में कोई हो रहा है, उनका कोई ब्रेक थ्रू स्टडी है, अगर है तो हम मानते हैं, अगर नहीं है तो फेक है और वो अपना चैनल चला रहे हैं। ठीक है, सो वी नीड टू रिक्वायर स्ट्रिक्ट एडहेरेंस टू मीडिया एथिक्स एंड प्रोफेशनल कोड्स Where these are lacking, they must be strengthened, and in that the government would play a very important role. Unfortunately, as I said, the government also has its tongue in cheek, and by that I mean that they are also not very open. Okay, you can look at this. I'm just sharing one algorithm which will help you understand how identifying this fake news will help or will be done. Can you see this page that I have shared? Is it visible?
Yes, sir. Yes, sir.
Yes, sir. So look at this. How do they compute fake news websites attributes? They open URL file for each title. Title starts with number 1, output file. Title contains and or how many punctuations, like exclamation marks or question marks. Then all words are capital in title. This is also unusual, just to attract the attention of the people. The other day I found out that if you are writing all in capital, that is like slapping people. Fine. So never ever write everything in capital unless and until you intend to slap somebody. Then they also count how many users left the website after visiting it. And this is about bounce back. And I said people will be greatly disappointed to find that the content which was promised is not the same as the title was suggesting. And you will have lot of such adult sites and lot of such, this is like page 3 news. I hope you understand page 3. The gossip pages related to celebrities, जिसमें तमाम तरह की गॉसिप होती है, जिसमें पता चला कि वो रणबीर सिंह की जगह रणबीर कपूर से वो शादी करवा दें. क्या नाम है उस हीरोइन का जिसकी शादी हुई रणबीर सिंह से?
दीपिका पादुकोण.
हाँ, दीपिका पादुकोण का वो उससे शादी करा दे. तो तमाम तरह की ऐसी फेक न्यूज आती है. ठीक है. सो users will leave these sites disappointed, and if you count it, they will count this and they will find out that this is a fake website. Title contains keywords. There are no keywords. Fine. So this is how they will do that. Okay. So, some of you can also develop this kind of a software in future where, such fake news sites can be identified and help people, save themselves and the entire nation or entire globe from spread of such fake news. So this is all about it, friends. If you have any quick query, I'll be happy to address that. Yeah, do you have any query? सब चुप हो गए भाई, तो इसका मतलब है कि we need to wind up. और मैं बता दूं कि इस हफ्ते तो नहीं, लेकिन अगले हफ्ते से हम लोग मंडे और फ्राइडे दोनों दिन मिलेंगे, एटलीस्ट 2 हफ्ते, so that we are able to complete our course. ठीक है. और ये स्लाइड भी मैं उस पे डाल देता हूँ. या okay, thank you very much. I'll upload this slide also.
Thank you, sir.
Okay, wish you all the best.